This last part of section 4.2 is talking about a shortcut for doing two-step percent problems. If you watch the last video, the last problem we did in that video was to calculate a sale price of an item. So we had a 70% off discount, and we had to calculate what 70% of the original price was and then subtract. So what we're talking about in this video is a way to do that in it's not really in one step. It's just that we're doing a step first before we do the percent problem. So look at this example here. It says an item is on sale for 20% off. So if you think of the original price as 100%, and that's the way we think of it, that's what we mean by the whole. That's the whole price, or the 100% of the price. With a discount of 20%, the customer is paying 100 minus 20%, or 80% of the original. So what that means is that 20% off is one way of thinking of it, or you can think of it as 80% on. So they're both thinking of the same thing. If we do the 20% off method, we're going to find 20% of our original price and then subtract it from the original price. If we use this method, all we're doing is doing that subtraction first. So we're saying, well, if you take 20% off of the whole 100%, there's going to be 80% left, and then we'll use 80% in the calculation instead of 20%. So here's another example down here. You leave 15% tip at a restaurant. Think of the cost of the meal as 100%, because remember that's the whole that you're applying the percent to. So when you add 15% for the tip, that means you'll pay the 100% that represented the whole meal, plus 15% for the tip, which gives you 115% of the original amount. So again, you could do this problem two ways. You could say, I'm going to calculate a 15% tip. Or you could say, and then after I do the 15% tip, I'd have to add it to the cost of the meal. Or I could just do it all at once by saying, I'm going to figure out what 115% of the meal would be. So sometimes this is useful, sometimes it's not. Some students really struggle to understand this idea. So don't let it get in the way of you understanding percent calculations. But if you see it as a useful shortcut, it's a good thing to know how to do. We do want you to know how to do this, so do practice it. Just don't let it get in the way of things if it really gets in the way of you understanding how to do basic percent problems. So we're going to look at this a different way. So the same kind of thing that we just talked about. So if we have 20% off the original, that's the same as 80% of the original being the new amount. So we're taking 20% off. That means we're going to wind up with 80% of the original. If we're adding 15% to the original, the new amount is going to be 115%. The 100% that was the original plus the 15% we added. So let's see how this looks on real problems. So this one says, Gretchen owns Gretchen's Gourmet Foods. When she sets prices for the items in her store, the percent of the markup depends on how quickly an item is expected to sell. For each item, write an equation to find the amount of the markup, and then solve the equation rounding to the nearest penny, and what will the price of the item be. So this says a pound of Arabica coffee is marked 25% more than its wholesale price of $8.45. So if you think about how that's going to work, we're going to have the wholesale price plus the markup, and that'll give us our retail price. And this really is how it works, of course, for any of you who've worked retail. So what we're looking for, if we do the two-step method, what we're looking for is the markup first. So we take our P equals RW, and we know the rate and the whole, because the rate is the 25%, the whole is the wholesale price, and what we're looking for is the part or the markup. So we have P equals, we make our 25% into a decimal, and the whole is, so we've written our equation, and now we're going to solve the equation. So P equals 2.1125 is what my calculator gives me, but then we're asked to round to the nearest penny. Nearest penny is right here, so I'm going to round down because the number next to it is less than 5. So I'm going to say that the part is $2.11. Now remember, we have to think about what does that part mean. We did 25% of the whole price, and the 25% is the markup. So that means to find our final price, because we had said that our price would be the wholesale plus the markup. So we're going to do $8.45 plus 211, and we'll get $10.56. I don't quite have room to write the sentence, but remember, you're always going to write yours as a sentence. So when it said, what will the price of the item be? The price of the item will be $10.56. So remember, the point here is that we did it in two steps. First thing we did was found the markup because we had 25% of the markup, and then we added it to the wholesale price. So now we're going to try doing it what I'm calling the one-step method, which is really not quite right because, like I said, it's not really one step. It's just that you're doing the extra step first, and sometimes it's a little simpler because you're working with smaller numbers or easier numbers to work with. So if we think of having a markup of 25%, that means the final price is going to be the 100% of the whole plus the 25% markup. So we're going to have 100% plus 25% is going to give us 125%. So then we can just start with that as our rate. So if we do P equals RW, so we're still looking for the part, and this is one of the places where this can seem a little confusing because the part is actually going to turn out to be bigger than the whole. But we know that we're looking for the part because the percent is going to apply to the 845, which means that that's the whole, because we're going to take 125% of 845. So if we make 125% into a decimal, we move the decimal twice, so we get 1.25. My calculator says that that's 10.5625. So we want it rounded to the nearest penny. So we look at the next number over. It's smaller, and so P smaller than 5, sorry, is 10.56. So the price of the coffee will be 10.56 per pound, right? And if you go back to what we did before, notice that's the same number we got before. It's just that we got it by this time first adding the percents together, getting a new percent, and then using that down in the equation. Two different ways of doing the same problem.